Hi everyone. I am sorry for the technical difficulties, but I think we are good to go. First of all, I really want to thank you all for joining today. I am excited to talk about this topic, the human edge in AI, building products with soul, as this discussion and focus on celebrating human agency are very close to my heart. So great AI products start with deep human understanding, not just technical capability. When we ground AI development in real user research and genuine human needs, we create tools that amplify rather than replace human insight. So the goal isn't just to create smarter technology, it's the technology that makes us more human. So can you please go to slide 2? Thank you. So this is the premise of our today's discussion, and here is the high-level overview of the topics. Big picture view, we are going to look briefly into NLP, LLMs, Gen AI, and AI agents, key industry examples, role of research and how it can be powered by AI. We will learn how UX research grounds innovation in real user contexts, human-centered AI, challenges and opportunities. This is the last topic that we will discuss, and we will talk about major limitation of current AI models and if we can minimize it by leveraging one high-level framework. And then we will dive into Q&A. Next slide, please. So before we get into the details, I want to set the stage. NLP, that is natural language processing, LLMs, AI, Gen AI, and AI agents, each play unique roles, yet they are deeply interconnected as each advance on the foundation of the others. NLP, that is natural language processing, forms the linguistic foundation. So what is NLP? NLP is the core foundation that enables machine to understand and respond to human language, transforming raw text, speech into structured meaning that computers can process, analyze, and act upon. So modern NLP uses machine learning to identify language patterns from massive data sets, which enables sentiment analysis, translation, and speech recognition. LLM. LLMs or large language models, they are the next evolution and are built upon the foundation laid by NLP. While NLP taught computers to parse and recognize text, LLMs learn to think through complex problems, generate coherent responses, and apply knowledge across domains. So, having trained on amounts of human written text, LLMs didn't just learn vocabulary. They absorbed patterns of human reasoning, problem solving approaches, and contextual knowledge. This enables them to not only understand what does this mean, but answer what should I do about it. So this reasoning capability and language powered intelligence has unlocked door to Gen AI and AI agents that follow. So talking about Gen AI, which is generative AI, represents the evolutionary leap from machines that understand and reason to machines that create. While LLMs learn to think through problems, Gen AI learn to produce original content, generating text, images, code, strategies, solutions that didn't exist before. So instead of just analyzing a marketing brief, it creates the campaign. Rather than just understanding financial data, it generates personalized investment reports. It moves from what does this mean to what should we create. The next one is AI agents. So while Gen AI learned to generate content and solutions, AI agents learn to execute complete workflows autonomously, coordinating multiple tools, data sources, and decision points to accomplish complex multi-step objectives. So the progression, I mean, this particular progression represents the full realization of artificial intelligence, systems that understand, reason, create, and act. Next slide, please. So let's briefly understand how we have landed here. And here are some very high level key milestones. So it all began in 1954 with Georgetown and IBM experiment. So Georgetown University and IBM came together for this experiment. So here, for the first time, a computer translated 60, that is 60 Russian sentences into English. It was a modest output, but its implications were profound. We come to 1960, Noam Chomsky's 1960s breakthrough in universal grammar transformed NLP from mechanical word swapping to structural language understanding. By discovering that all languages follow universal patterns, Chomsky gave computer scientists their first roadmap for teaching machines not just vocabulary, but the deep rules that govern how language works. So this breakthrough shift, it shifted NLP from crude word-to-word translation to genuine understanding of syntax, grammar, and linguistic structure. We come to 1980s and 90s. It brought these particular years brought fundamental shift. So instead of programming language rules, machines began learning patterns from massive text datasets. This data-driven approach using statistical models and machine learning made NLP far more accurate and flexible. And here we come to 2001. In 2001, Yoshua Bengio and his team introduced the first neural language model. Unlike previous rule-based and statistical systems, Bengio's model didn't just count word frequencies or follow programmed patterns. It learned to represent each word as a d-dimensional feature vector, what we now call as word embeddings, allowing machines to understand that words with similar meanings should have similar mathematical representations. This marked the shift from rigid pattern matching to flexible understanding that ultimately led the AI revolution we see today. 2010, where things started moving very fast. 2010 marked the beginning of the deep learning revolution made possible by GPU computing power that was 70 times faster than CPUs, reducing weeks of work into days. This computational breakthrough enabled training of much larger neural networks that had previously been impractical. So 2010's deep learning infrastructure, which enabled word-to-vec and glove word embeddings models that paved the way for modern LLMs. Google's sequence-to-sequence models for machine translation in 2014, it was a big breakthrough. Google's BERT, which is bidirectional encoder representations from transformers, which came in 2018, revolutionized language understanding by reading text bidirectionally, processing words in relation to all surrounding context, not just left to right and previous models, like all previous models. So BERT established kind of a template for modern language models, large-scale pre-training on diverse text, followed by task-specific fine-tuning that powers today's AI systems. So 2020 onwards, we know what came in 2022. AI systems grew highly multimodal. They won't just process text, they will fluidly combine language, images, video, voice, sensor data, which enables richer interaction and deeper context understanding. drop builders, natural language prompts, and pre-built AI components have kind of empowered non-technical professionals to create, test, and deploy AI solutions, reducing dependence on engineering teams. We all know vibe coding and Figma's no-code prototyping features. We all have experimented with them, are some of the best examples of these. Slide 5, please. Thank you. So AI doesn't work in isolation. Our orchestration connects the pieces into one seamless system. So agentic orchestration is like a conductor leading an orchestra. So instead of violins and drums, it coordinates different AI systems, data sources, and tools so they work in harmony. It connects the whole stack from the chips powering AI, that is Intel, NVIDIA, to the cloud platforms that store and move data like AWS, Snowflake, to the big AI brains like Sonnet, GPT, Gemini, Llama. The result is phenomenal. Developers can build AI applications more smoothly without worrying about the messy plumbing underneath. Next slide, please. So let's put what we discussed so far into the context and look at some industry examples. So first example that I want to discuss is how GitHub Copilot by Microsoft is helping developers build fast. So Microsoft's GitHub Pilot helps businesses shift fast by optimizing and automating developer workflows. It's an AI coding assistant that provides contextualized suggestions so that one can code better, faster, and write better, test documentation. So here are some key capabilities of GitHub Copilot. First is code debugging for fast software delivery model. Second is GitHub's Copilot's coding agent can review codes independently, autonomously, without any continuous interaction. Developers can delegate code review tasks to the coding agent and focus on more value-focused activity. The third is multi-agent functionality, which allows multiple agents, work together autonomously to resolve issues at hand. For example, code review agent reviews the code and passes it to the code agent who, based on feedback, rewrites the code. Code agent then sends the code to security agent. Security agent flags a bug and sends it back to the code agent to fix it. So towards the tail end of it, as your code gets ready for deployment, SRE agent comes into the picture. SRE stands for site reliability and engineering, and SRE agents are responsible for application performance monitoring and observability. So if SRE agent identifies any problems, it's gonna make a call to code agent, and again the same sequence or cycle is repeated. So fourth capability here is depending on the task at hand. Copilot allows you to pick an LLM. Anthropic, Google Gemini, OpenAI models are available, and the latest addition is XAI's Grok models. You can see that in the picture here as well. So in short, GitHub's Copilot is evolving from being assistants to collaborators. They have built deep context awareness and integrate across the dev stack from like IDE, documentation, version control, CI/CD, observability tools. They are providing context-aware support that feels seamless. This empowers human developers to be architects and systems thinkers and problem solvers and problem framers who can decide what to build and be critical reviewers and thinkers and creative innovators. Next slide, please. Here is another example, which are like from telehealth and fintech. So I'm going to talk specifically about the telehealth example. AI tech is transforming these domains from reactive consultations into systems that orchestrate complex data analysis to deliver proactive advice. So, as I said, let's dive into the telehealth example. So, NLP. NLP, natural language processing, understands medical language. It extracts unstructured physician notes, converts into the coded systems and severity levels. For example, patient reports intermittent chest tightness with exertion. So this specifically coming out of NLP processing. Voice to text systems transcribe virtual consultations, and NLP identifies key medical terms, urgency indicators, and treatment history references. It also scans thousands of patient records to identify patterns and extract relevant medical history. LLMs provide medical reasoning and context. LLMs can analyze patient symptoms within medical context and suggest potential diagnosis considering patient history, demographics, and complaints. LLMs can provide real-time support to physicians during telehealth calls by cross-referencing systems, medical literature, treatment protocols, and patient-specific factors. Gen AI. Gen AI can create customized treatment plans, lifestyle recommendations, easy to understand explanations, and comprehensive visit summaries that follow up instructions. And last but not least, AI agents jump in, and AI agents manage and complete patient journeys, complete end-to-end patient journeys, scheduling appointments, arranging pre-visit symptom assessments, coordinating lab results, ensuring follow-up compliance. Agents can also orchestrate complex cases involving multiple specialists, allowing experts to decide when to intervene. So this telehealth AI stack transforms telehealth from simple video call into intelligent proactive healthcare that anticipates needs and coordinates care while preserving human judgment. Next slide, please. So these are the two examples that highlight a critical focus on deep understanding of user workflows, mental models, pain points, and aspirations. This lays foundation for building products and experiences that customers need, want, and love. So latest MIT report, the Gen AI divide, state of AI in business 2025, it has revealed that 95% of Gen AI pilot programs are failing to deliver measurable business impact. MIT researcher says generic tools like ChatGPT excel for individuals because of their flexibility, but they stall in enterprise use since they don't learn from or adapt to specific domain focused workflows. This is where UX research can add tons of value and ensures domain tons of value and can ensure domain specific solutions for enterprise and SMB sectors. And can help them focus and deliver user focused solutions. UX researcher can help identify domain-specific products and feature opportunities that boost human AI collaboration early by diving deep into the user workflows. This type of research can further influence overall business strategy and product roadmap and shape value-driven business investment and product development. So using mix of variety of methodologies, like a mix of deep dive to hands-on mixed methods from ethnography, interviews, diary studies to surveys, concept walkthroughs, mental model alignment testing, Wizard of Oz testing, where humans simulate AI responses during user sessions to test AI concepts before building complex systems, or progressive disclosure studies, which test how much AI reasoning to show users. Too little can cause distrust, too much can create cognitive overload. A/B tests and feature flag testing, UX researchers can drive user value, trust, and competitive advantage of AI products. And that's why role of UX research is extremely important, critical, especially when we are building AI powered or AI native solutions and products. Next slide, please. So we continuing with the role of research and how it can be powered by AI. I want to add that we reviewed some couple of examples and industry specific examples. We saw GitLab Copilot's example, and we also talked about telehealth. Similar to those, using AI tools to optimize UX research processes can drive turnaround time and productivity. And here are some examples, because AI automates UX research grunt work like transcription, pattern detection, and initial synthesis, while researchers can focus on decision making, strategic insights, and delivering impacts. We also live in a world where the product development is much faster. And as a UX researcher, I have always worked on ensuring that UX research is not seen as a hurdle or a problem, or rather seen as an amplifier. So taking care of the timeline issues has been always been my priority throughout my career. So giving some examples of how it can be powered by AI, we can have AI-powered data collection tools. There are a lot of agentic AI-powered platforms right now that run interviews and surveys and testing, and there are also ops platforms that are reducing the research timelines. The second is AI tools for data synthesis and analysis. So Copilot, Gemini, and platforms like Dovetail AI, Marvin UXR, Dscout, etc. are accelerating insight generation. AI-powered recruitment, automation, synthetic users, and smart filtering and mapping are dramatically evolving recruitment. And last but not least, AI-supported insight sharing, which is there are foundational models, ChatGPT and Claude. Many a times I use them to refine my storytelling and refine my insights. These foundational models are playing a key role in storytelling, content refinement, and report building. Next slide, please. So here we are, like kind of towards end of the presentation, but what are the challenges and opportunities? We saw that there are a lot of optimization and automation and augmentation opportunities and benefits, but there are also some major challenges that we are experiencing right now. So AI tools shape millions of users' perception daily and impact their product interactions. Even a small bias can amplify real-world inequalities, dangerous outcomes, and deep frustrations are at unthinkable level. I want to share two specific examples here. This is the recent UNESCO study that found alarming gender bias in major AI language models. So systematic gender bias. So UNESCO study found that there was a high bias against women and girls in large language models. They examined major AI systems, including GPT 3.5, GPT 2, and Meta's Llama 2, finding unequivocal evidence of bias against women across all platforms. The second is professional stereotyping. AI models consistently assigned diverse high status jobs like engineer, teacher, doctor to men, while relegating women to traditionally undervalued roles like domestic servant or cook. Women were described in domestic roles 4 times more than that of the men in Lima 2 generated content. So, narrative differences, stories about men featured words like treasure, adventurous, and decided, while women's stories emphasized garden, love, gentle, hair, and husband, reinforcing limiting stereotypes about women's roles and capabilities. And here is another very interesting study by World Values Survey. So this study, it was a major study, AI model across they studied AI models across 107 countries, and it was revealed that systems reflect Western, European, English-speaking cultural assumptions, completely missing how people in Africa or Latin America and in the Middle East communicate, build trust, and revolve conflicts, and evolve or resolve conflicts. So, cultural neutrality is impossible, but making sense of how AI outputs are filtered through specific lenses of global diversity earlier in the product development is extremely critical. So, this emphasizes that one size fits all model is bound to fail. Companies developing cultural awareness will succeed the most. Next slide, please. Yeah, this is another major problem with most of these models. There is a Anglophone bias, which refers to AI systems unconsciously adopting perspectives and communication styles and cultural values of English-speaking societies, primarily the US, UK, Canada, and Australia, while overlooking how the majority of the world actually thinks and communicates. So English speakers represent only 15% of the world's population, yet their cultural assumptions drive AI systems used by other 85%. And this creates AI that works well for some cultures and while being tone deaf or inactive or biased, even offensive in some cases to others. So how this happens? So training data dominance. So most AI models learn from English language, internet content, which and mostly the published text, which represents only a fraction of global human experience, but dominates available digital text. Research concentration. So AI development is concentrated in English-speaking tech hubs like we know Silicon Valley, London, Toronto, embedding Western assumptions about normal human behavior into system design. Cultural pattern absorption, like AI models learn that English speaking patterns of directness, individualism, and efficiency are correct ways to communicate, missing entirely different cultural approaches to respect, relationship building, and problem solving. That's why localizing Gen AI is essential. Investment in understanding subtext, nuanced culture and language patterns, and embedding those into the AI models is one of the way we can preserve humanness of the AI systems and product experiences that they deliver. Next slide, please. Here is a high level framework that I recommended. Everyone should keep this in hand, keep this handy when building any product or business or, designing a simple outcome. This is something that we all can do at our level. First is design well. Typically, design or UI is your first line of defense. So clear warnings, visual indicators, and plain English explanations of risks to guide your users effectively, not to confuse them, is extremely important. Second is evaluate everything. Test concepts with real users for usability, understanding, and trust. And don't stop there. AI models need ongoing evaluation too, especially for edge cases and diverse cultural representation. Third is context is king. We have always said that devil lives in details. So understanding nuanced meanings and subtexts and cultural differences at a very ground level is extremely important. Early research is everything. Understand the full range of use cases before building, map them against big data, real user personas, and mental models. And last but not the least, reboot your culture. This all comes down to organizational values. How does an organization balance moving fast with doing right by its users? What guardrails ensure research insights survive the hands off between the teams, and how do the teams keep learning continuously, and how that learning is democratized and evangelized across the company from top to bottom and from bottom to up. So this brings us to the last slide of my presentation. Next slide, please. So I hope you enjoyed this presentation. I'm looking forward to answer any questions you have.